Hello everybody, my name is Steve French, but you can call me Frenchy. I'm from Warren, Pennsylvania, and right now I'm doing the week 1 assignment for Coursera's Intro to Music Production class. Today is July 29th, 2013, and I'm going to be doing the type and usage of two very important studio cables. So let's get started. So the first one is the 1/4 inch instrument cable. You can see I'm holding one right here, and there's two conductors. This right here is the tip, and this right here is the shield. And you may have heard the term high Z or high impedance. Impedance is very, very, very related to resistance. And a little simple Ohm's law thing here, voltage equals current times resistance. And you'll notice that for a given voltage, as the resistance goes up, the current goes down. And the reason that they use high impedance here is because this is a passive guitar pickup. There's no batteries, it cannot provide a lot of current, it cannot provide a lot of power. And so what they do is they keep this resistance very, 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 very high so that the current can stay very low. Because actually when you use a resistance, when you load down this pickup, with a resistance that's too low, then that's exactly what it's called. It's called loading down the pickup, and the high frequency response suffers, the output voltage suffers, and when you keep the resistance very, very, very high, then this is able to generate its voltage and do its job without the soul getting sucked out of it. So that's why high impedance is very important, because it keeps the resistance high so that the voltage, or so that the current can stay low. And then it goes into an input like a direct box or some other input interface. In my case, it's an Avalon U5 direct box, but the input impedance here is very high so that it does not load down the pickup. And here you see that you have a tip shield and a tip shield on each side. So the shield is the one ground reference, and then the tip is the one signal that comes through. Typical length of this unbalanced audio cable is less than 20 feet because it's very susceptible to noise. Now we're going to move in to one of my favorites, the balanced audio. So an XLR cable is this right here, and notice how it has 3 conductors that I'm showing here. And in a balanced audio type situation that I want to talk about now, you have a signal plus right here, and then you have a signal minus. It's the exact same signal, but it's inverted, otherwise known as it's out of phase by 180 degrees, so it's inverted. It's the exact opposite. When this one goes up, this one goes down, and vice versa. The third pin is a ground reference shield, just like before. But here we have 2 signals. This is awesome. Let me tell you about this. This gets me excited. So when this signal goes up, this signal goes down, as I said. Well, these 2 signals are a twisted pair. They're very tightly coupled in physical space. So when this little bump here is a simulation of noise. When noise comes in from some type of interference, it hits the positive signal like this. It also hits the negative signal, because these are twisted pairs, remember. So when the noise impinges here, it also impinges here. Now, this is where the magic happens. At the receiving end, what they do is they take this signal here and invert it, flip it over, and add the 2 together. So look what happens to the audio signal here when you flip it and add it together. The audio signal doubles. But what happens to this noise? The noise cancels, because you have plus noise here, minus noise here. Whatever noise happens actually cancels, while the signal itself gets twice as strong. Typical length here is hundreds or even thousands of feet. In concerts, they use it to go from soundboards up to stage. It goes hundreds of feet, and it's actually used in DMX, and it's used in Cat 5 cables. This is an example of a DMX cable I made out of Cat 5, and you can run thousands of feet. The spec says 4,000 feet, I think. So balanced is not just used for audio. It's used in all kinds of industries, like I said, Ethernet, DMX, etc., 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 RS-485 standards in general. All right, so bring it on home here. That's it for today. We're going to keep this short and tight. We talked about a balanced audio signal, which in this case was XLR, but it can be used on TRS and other transport mediums. But we talked about balanced, and we talked about instrument cable, and we talked about high Z and how to not load down the pickups so you don't ruin your signal. All right, signing off for today. This is Frenchy. Have a great day.